All right. So, probability, this first lesson, we are only going to be looking at ways that you can count certain things because whenever you calculate the probability of something, we have to know the outcomes in that specific event and we need to know the total number of outcomes. So, what we're doing in this first lesson is we're just looking at different exercises and we're going to be calculating the number of ways for all of these things to occur. So the first part is over the fundamental counting principle. The fundamental counting principle is just the number of ways in which a series of successive things can occur, and it's found by multiplying the number of ways in which each thing can occur. So what this is the number of possible outcomes in a given situation. So let me write that off to the side. Number of possible outcomes in a given situation. And it says that you can find it by multiplying the number of ways in which each thing can occur. So I do have a PowerPoint that I want to show y'all just so y'all can see all of the different ways that these things can occur. So all the exercises I'm going to show you with the PowerPoint just for this first part. Says an ice cream store sells 2 drinks. You have sodas or milkshakes. You have 4 different sizes: small, medium, large, or jumbo. And then you have 5 different flavors: vanilla, strawberry, chocolate, coffee, or pistachio. In how many ways can a customer order a... So these are just all the different ways. If you can see, you have your drink choices, the 2 choices, and then you have the 4 sizes, and then all of the flavors for those sizes. So you have the 2 drinks, the 4 sizes, the 5 flavors, and whenever you multiply them all together, you have 40 different drink choices. So that's mainly what we're doing is the fundamental counting principle. We're just multiplying the number of ways for each different thing. So your answer on the first exercise is 40. Exercise 2. It says that you are taking a multiple choice test that has 5 questions. Each of the questions has 3 answer choices with 1 correct answer per question. If you select one of these 3 choices for each question and leave nothing blank, in how many ways can you answer the questions? So this one is different than the first exercise. The first exercise, we're choosing 1 drink. This exercise, we're choosing 5 different things. So if you look at the different questions, the first question, second, third, fourth, and fifth, you can choose like A, B, or C. It doesn't say A, B, or C, but it says that we have 3 choices for each question. So since we have 5 different choices, we're going to multiply the 3 choices 5 times. So 3 times 3 times 3 times 3 times 3, which is 3 to the 5th power. Exercise 3. In the original plan for area codes in 1945, the first digit could be any number from 2 through 9, the second digit either 0 or 1, and the third digit could be any number except 0. With this plan, how many different area codes are possible? So the first digit, it can be the numbers 2 through 9. The second digit is either going to be 0 or 1, and then the last digit is going to be any number except 0, so that would be the numbers 1 through 9. So we have 8 options for the first digit because we have the numbers 2 through 9, 2 options for the second, and then 9 options for the third. And when you multiply those, 8 times 2 times 9, we have 144 different area codes. All right, exercise 4 is a license plate. It says a license plate in a particular state displays 2 letters followed by 3 numbers. How many different license plates can be manufactured for this state? So we have 2 letters and then 3 numbers. So we have the letters A through Z for possible options for the first and second box, and then we have the numbers 0 through 9. We're only looking at those because it's just one digit. We can't do 10 because that wouldn't fit in the one digit. So it'll only be the numbers 0 through 9.
So then for A through Z, okay, never mind. That just answered it.
So yes, there's 26 letters, A through Z, so we would multiply 26 times 26 and then times 10 times 10 times 10, because there's 10 single digit numbers. You'll use this information later on whenever we start calculating probabilities. All right, the next part of the lesson, we have permutations and combinations. So anytime you have an ordered arrangement of items, we can either be looking at permutations or combinations. Permutations are whenever the ordered arrangement makes a difference. So the order matters. The order of the items matter. So that's like first, second, third place. That order matters. President, vice president, they'll ask you stuff with that. So to find the number of ways for items to be arranged, we use the permutation formula. So the permutation formula can be found using this right here, but the way that we calculate it in this class is with the calculator. So the NPR formula is what you want in your calculator, and that can be found by clicking on math. Let me skip this over. Math, and then you scroll to the right over to probability, so you can use your arrow and go over. And we have NPR and then NCR. So we'll use the NPR formula for the permutations and then NCR formula for the combinations. So I do give you the formula because it is cool to see how stuff is calculated using your calculator, but we're going to use the easy way. We're just going to use one of these formulas. If you scroll down and click enter, and then it should give you the 2 boxes with the P in the middle. Okay, so a factorial is just a product of all positive integers from a number down through 1. So let's say if we have 3 factorial, we're going to multiply starting at 3 and then go down to number 1. So this can also be calculated easily with your calculator, doing the same thing. If you click on math and probability, the factorial is below NCR. It's that exclamation point. Okay. So you'll have to put your number first. If we do 4 factorial, we'll put the number 4, and then we'll go over to math, probability, and then make sure the exclamation point is after, and click enter, and it'll calculate it for you. So, and then we have this formula right here that we will use at the end of this part. It says the permutation of duplicate items, the number of permutations of n items where there are items that are identical and they name them with P, Q, and R, and so on. And so we'll use this formula. So the first exercise, we're just going to be evaluating each factorial expression. So you can put this in your calculator exactly how it is. We can create a fraction, or you can just do 9 factorial divided by 6 factorial. So probability 9
504.
factorial. What'd you say?
504.
504. Yes, thank you.
Where'd you get the factorial again? Where's that at?
Math
Probability.
probability.
Oh, there it is. Right.
So let me put that, the calculator, math, and then probability is where you'll find everything. So yes, the first one was 504. Letter B, we have 31 factorial divided by 28 factorial.
26,970.
26,970, thank you. On C, we have 7 factorial divided by, and then we have 7 minus 2 in parentheses, and we have the factorial after that. So we would do 7 minus 2 first, and then put the factorial. So 7 factorial divided by 5 factorial.
42.
Yes. Alright, and then same thing for our last one. It would be 13 factorial divided by, and then we have 13 minus 3 would be 10 factorial.
$1,716.
Yes. Alright. Now we're getting into the word problems. So they're going to give you a certain situation, and we know on these that these are all going to be permutations, but on your homework, when you do start calculating probability, they're not going to tell you that it's a permutation or a combination. So we, like I said, we always want to see if order matters or if it doesn't matter. In this particular question, we have president, vice president, secretary, treasurer. So we know that order matters anytime we have something like this. So it says that a corporation has 7 members on its board of directors. In how many different ways can it elect a president, vice president, secretary, and treasurer? So we have 7 members in our group, and we are selecting 4 different officers. So we have president, vice president, secretary, and treasurer. So order matters, so we know that we're looking at a permutation. So we're going to use that NPR formula. The way that this works is we have to figure out what N is and what R is. N is going to be the number that we are choosing from. So number that we are choosing from. So in this case, we are choosing from the 7 members on its board of directors. So N is going to be 7. And then R is going to be what we're choosing. So the number that we're choosing. Let me scooch that over. Number that we are choosing. So in this case, we're picking 4 people. We're doing a president, vice president, secretary, and then treasurer. So it would be 7P4 is what gets put into our calculator. And if that confuses you, just remember that the bigger number always comes first and then the smaller number. So math, probability, and then NPR. And then we would do 7, and we're picking 4. So 840 different ways that we could do that. Any questions?
Will there be any cases where the bigger number is not always in?
No, the bigger number always comes first.
Okay.
It could be equal. They could both be 7. Like, if you have 7 members and you're picking 7 different things, you could do 7P7.
Okay.
All right, the next one, it says, in a race in which 6 automobiles are entered and there are no ties, how many ways can the first 3 finishers come in? So a race is always going to be a permutation because the order matters for those racers, whoever it is. So
six point three.
yes, we have 6 total cars and we have 3 finishers. So math, probability, 6P3, 120. Everybody okay? All right, this last part for the permutations, we are using that duplicates formula. So the formula from the first page, I'll just rewrite it. Duplicates formula, we have n factorial divided by p factorial times q factorial times r factorial. Now, these that are on the bottom, p, q, and r, it doesn't always have to have 3 of them. You could have 2 duplicates, 3 duplicates, 4 duplicates. The bottom is going to change with how many duplicates that you're looking at. So we are looking at 2 different words. We have science and then Tennessee. So science, starting with our n, we need to figure out how many total spaces what we're looking at. So S, C, I, E, N, C, E. We've got 7 spaces. So n is going to equal 7. The duplicates in this case are the letters that are duplicated. So we've got C in there 2 times and we've got E in there 2 times. So in this case, we don't use all of P, Q, and R. We're just going to have P and Q. So P equals 2 and then Q equals 2. So when we set up our formula, we plug everything in. We have 7 factorial divided by 2 factorial times 2 factorial. So alpha equals enter. We've got 7 factorial on top times 2 factorial times 2 factorial, which is just 2 times 2. And you should get 1260.
You said we didn't have more.
Is this what you needed?
Yes, thank you.
All right, what about Tennessee? So n is going to be the total number of spaces. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. And then what are our duplicate letters? We've got E, which is in there 4 times. We've got N, that's in there twice. And then we have S, that's in there twice. So P, if we did E is E for P, then we would have 4 of those. Let me just, I guess I'll just do it like that. Q equals 2 for the 2 N's, and then R equals 2 for the 2 R's. I mean, 2 S's, sorry. Having the different letters is confusing. So we've got n factorial divided by 4 factorial times 2 factorial times 2 factorial. Okay, so clear.
got 3780.
Yes, 3780. Thank you. Any questions? All right. The last part of this lesson is over combinations. So we talked about permutations where order matters. A combination is where order does not matter. Order does not matter. So it doesn't matter if you are chosen first or you're chosen fifth, you still get picked, then it's a combination. So stuff like lotteries or the first exercise where you have 3 winners all that have the same prize. It doesn't matter if you're chosen first or third, you still get picked. So that is a combination. So we'll use the NCR formula for the combinations. So the first exercise, it's asking you, does the problem involve permutations or combinations? So we have both of these. There's 50 people that are purchasing raffle tickets, and we have 3 winning tickets that are selected. In A, it says that the first prize is 1,000, the second prize is 500, and the third prize is 100. So in this case, order does matter. So since order matters, is this a permutation or a combination? Permutation. Okay. So we would use the NPR formula. We're not going to actually calculate it. We'll calculate them down below. For part B, it says that each prize is $500. So in this case, it doesn't matter if you're selected first or third, you still win $500. So order does not matter, which makes it a combination. All right. On the next exercises, I think there's 3 of them. So I think all of these are going to be combinations. Number 2 says an election ballot asks voters to select 3 city commissioners from a group of 6 candidates. In how many ways can this be done? So this is a combination because it doesn't matter if you're selected first, second, or third, you still get selected to be a commissioner. So it says we have a group of 6 candidates and we are selecting 3 commissioners. So using our NCR formula, we have 6 and then we're choosing 3. So 6C3. I think we calculated that up here, didn't we? 6C3? Oh no, that was P3. So what'd y'all get for 6C3? Or do y'all want me to do it?
20.
20, thank you. Alright, what about the lotto? It says to win the lotto in the state of Florida, one must correctly select 6 numbers from a collection of 53 numbers, 1 through 53. The order in which the selection is made does not matter. How many different selections are possible? So we have 53 total numbers that we're choosing from, and we are going to correctly select 6 numbers from that collection. So NCR would be 53C6, which is
22,957,480.
yes. So that means that your probability of winning that lottery is 1 out of that 22,957,480.
But I can win.
Do what?
So, but I can win.
It can happen. All right, the last one, it says, how many ways can a committee of 4 men and 5 women be formed from a group of 7 men and 7 women? So we have our combinations of men and then women. So we're going to find both of these and then we'll multiply them together. So it says the men, we have 4 men. We want to choose 4 men from a group of 7. So it would be 7C4. And we would multiply that with the women, which we have 7 women and we're choosing 5. So 7C5. So you can do these separately in your calculator, or you can put it in just like that. Like math probability. So 7C, what was it, 4? And then multiply by 7C5. And you should get 735.